Lecture problem 2. A wheel is rotating at 30 rpm. The wheel then accelerates uniformly to 50 rpm in 10 seconds. Determine the rate of angular acceleration in radians per second squared and the angular displacement of the wheel during the 10 seconds. This is clearly a rotational kinematics question, and it is not that much different from the one-dimensional kinematics that we have learned early on in the semester. The information that is provided to us in this question is the initial angular velocity omega 0, which equals 30.0 rpm, which stands for rotation per minute. We also been provided with the final angular velocity, which is equal to 50.0 rpm. Those two units are not SI units, and they need to be converted to radians per second. First, the omega 0 equals to 30 rotation per minute we know that one rotation equals to 2 pi radians, and the 1 minute equals to 60 seconds. The rotations cancel, the minutes also gonna cancel, and the omega 0 is going to equal pi radians per second. In a similar way, we can convert the final angular velocity, which is equal to 50 rotations per minute. One rotation equals to 2 pi radians, and the 1 minute equals to 60 seconds. Solving for the final angular velocity, we obtain 5.24 radians per second. To be able to solve for part A for the angular acceleration, the best kinematics relationship that fits our given information is the following. Omega final equals omega initial plus alpha t, where the time t is given to equal 10 seconds. Therefore, isolating the alpha, you obtain omega minus omega 0 divided by the time t. Solving for the angular acceleration alpha, we obtain 0.21 radians per second squared. Now that we have solved for the angular acceleration, any one of those remaining kinematics equations can be used to solve for the angular displacement. The angular displacement theta, according to the first equation, equals theta 0 plus the initial angular velocity times the time plus 1/2 times the angular acceleration alpha times the time t squared. Set your initial angular displacement to equal 0. Substituting for the remaining known quantities, omega 0 was found to equal pi times the time t, which is 10 seconds, plus 1/2 times the angular acceleration that we solved for, which equals to 0.21 times the 10 seconds squared. Solving for the angular displacement theta, we obtain 41.9 radians.